1t, 2t, 4t, so on. Okay? So that's another way to, review. We didn't do it yesterday, but this is another way to actually see how to decompose a signal, right, into different resolutions. Any questions here? Now, if we compare phi of t, which is the basis function in V0, and phi of 2t, which is the basis function in V1, we know that I can combine, right, this to get that. Or I may combine this to get that. So I know that V0 is in V1. So I can write phi of t, this linear combination of phi of 2t. It's not k, 2. But the weighting factor that we use to represent is actually 2 h naught of k. In this example, what is h naught of k? There are 2 here. So it's 1/2, 1/2, right? If I take this and I shift it by a half, add together, I get this one. So there are 2 terms in here, right? The term where k is 0 and 1, and the quantity is 1 and 1. So it's 1/2 and 1/2. In this example here, h naught have value of 1/2, 1/2. You recognize that this is r, right? R is 1/2, 1/2. So again, r is a basis function that is piecewise constant signal. Okay, so r you'll be able to represent piecewise constant signal. Okay. Furthermore, I also notice that W naught of t, W of t, also in V1, right? Because W of t looks like this. Right, that's W of t. So I can combine this with the shift and flip. Okay? So in general, right, I have W of t, which is a smaller space, right? With 2 summation h1 of k, phi of 2t, k. So both are called the dilation equation, right? For dilation equation. And in this example, in the hard example, what is h1? 1/2 minus 1/2, right? Because if I take t and I shift it by 1/2 and flip the value, so I have 1/2 minus 1/2, and that will give me W of t. Okay. Now this. So this particular quantity here is only for r, but in general, right? In general, if you construct it like this, you have various for phi of t. Okay. So what I'm going to do next is we're going to take this dilation equation and we ask the question: given h naught and h1, how do I find the corresponding basis function for those spaces? Okay, so there are several ways of doing this. I will show you 2 ways. One is the brute force. It's hard to do, but let's do it anyway to see what's going on. And one is a much faster way to do this. Okay, so the next topic is taking the dilation equation and discussing way of how to find phi of t and W of t given the coefficient h0 and h1. And yet we recognize it here also that h0 is the low pass filter associated with the filter bank construction, right? Because in this step, as an H naught down by 2, H1 down by 2. Okay? So that's what we're going to do next. To take this equation and discussing way to solve it. Okay, this is in the book. This is called Cascade Algorithm. I'm going to discuss one of them, and you can generalize it to the other one. Okay, let's stay with the first equation. What it will say is that I can do the following. I'll have an iterative process. I can start with the initial form for phi, and I can iterate it. Okay? So at the I plus 1 iteration, it will be built on the I iteration. So it will be 2 summation in K, it's not of K, I 2t minus k. If it's converged, right? You know, if I go to infinity, it will converge to a closed form expression or a curve that you can plot, right? And let's take the case. So we have several different examples, okay? And we choose phi naught of t. The initial condition for phi to be a box from 0 to 1. Now the book has several exercises. As long as for all the choice of phi naught of t, as long as you have unit area, you can prove that it's always converged to the same solution. But you're not going to have to prove that, okay? But the book has some exercises. If you look at the section on this topic, you actually have a problem that shows that. Okay, but the first easiest one to do is using a box from 0 to 1 with 1 to 1. So that's kind of area, unit area 1. Okay, so let's take several examples. Take the case, the hard case. Okay, where the filter is 1/2, 1/2. So what I'm going to do next is, we're going to take this example, which we know the solution already. Right? That's the solution. Okay? Take this, let's go through the process, look what's going on. Take this example and plug it into here and see what happens. So it implies that the I plus 1 iteration will be 1/2 times 2 is 1. Okay, so I have phi of 2t at the I iteration plus phi of 2t minus 1. Alright? In this case, the book we have phi 1 is phi 0 of 2t plus phi 0 of 2t minus 1. Right? So let's plot them. Phi 0 of 2t is that. Okay? That's phi 0 of 2t. And what is phi 0 of 2t minus 1? It's the same, shifted by 1/2. Right? Because 2t minus 1 shifted by 1/2. So that will be your phi naught 2t minus 1. So in one iteration you converge. So this is the ideal case, right? The easiest example where no iteration. What you start out with will be your solution. Okay? Alright. Take another example.